Hi everyone, good day. Welcome back to our next video. In this video, let us understand the concepts of data types and variables. What are data types? Data types determines the possible values that a variable can have and the valid operations that can be applied on it. Say for example, if I am declaring a variable as an integer, then it is only possible to hold an integer value in that particular variable. We cannot hold a character value. Based on this, data types are broadly classified as basic data types or primitive data types, derived data types, and user-defined data types. The primitive or the basic data types includes char, int, float, double, and void. Char data type is used to declare a variable as character, which means that that particular variable can hold a character value. So if you want a variable to hold an integer value, then you can declare the data type as int. For holding fractional values or decimal values, we can use float data type or double data type. So we have two data types here. So it is based on the range of values. Suppose if it is a single precision floating point value, it can be referred by using float. Double precision floating point value by using double. So if there is no value, we are representing the variable as a void. Void means no value. So along with this primitive data types or the basic data types, we can prefix it with some type modifiers. So what is a type modifier? They are used to modify the base type to yield a new type, which means that it modifies the range of values that can be held by the particular variable and the properties, arithmetic properties of the base type. So we have few type modifiers like signed, unsigned, short, long. These can be used along with the basic data types. Say for example, when I say signed int, when I declare a variable as signed int, it means that the variable can hold both positive value as well as negative value. Suppose if I say it is unsigned int, then it means that the variable can hold only positive values. So it cannot hold negative value, it can hold only positive value. This table gives information about the size and range of values that can be held in this primitive data types. For char, we require 1 byte of memory for holding the character value. The range of values that can be held in this variable is minus 128 to 127 plus 127. For unsigned char, so unsigned means it can hold only a positive value. We require 1 byte of memory. The range of values that can be held is 0 to 255. For int, 2 bytes of memory. The range of values minus 2 power 15 to plus 2 power 15 minus 1. For unsigned int, we require 2 bytes. The range of values, as it is unsigned, it holds only positive value. So from 0 to 2 power 16 minus 1. Short int, 1 byte, minus 128 to plus 127. Unsigned short int, 1 byte, 0 to 255. Long int, 4 bytes, minus 2 power 31 to plus 2 power 31 minus 1. Unsigned long int, 4 bytes, 0 to 2 power 32 minus 1. Float, 4 bytes, 3.4 e minus 38 to 3.4 e plus 38, which means that 3.4 into 10 to the power minus 38 to 3.4 into 10 to the power plus 38. Double, so double the size, 8 bytes of memory space is required for holding the double value. The range of values is also more. It can accommodate values from 1.7 e minus 308 to 1.7 e plus 308. So this means that 1.7 into 10 to the power minus 308 to 1.7 into 10 to the power plus 308. Long double, again this is the longest range of values. So it requires 10 bytes of memory and the range of values is from 3.4 e minus 4932 to 1.1 e plus 4932. What are derived data types? The data types which are derived from the basic data types or the primitive data types are called derived data types. Derived data types include array, pointer, function. Arrays, we already know that a single variable can hold a single value, but when we want to store more than one value, it cannot be done in a variable. So we need another data type where we are using this array data types. Arrays are used for holding homogeneous data. They hold a collection of data, but the data should be of the same type. Then we have pointer. Pointers are variables which hold the address of another variable. So it does not hold the data value, instead it holds the address of another variable. Another data type is the function. They are used for performing a specified task. When you want to perform a specified task, it can be done by using the function. C language provides a rich set of primitive and derived data types. In case these data types do not suit our requirements, C language also provides the flexibility to create new data types. These data types are known as user-defined data types. We can create user-defined data types by using structure, union, enumeration, and typedef. A structure is a collection of variables under a single name and provides a convenient way of grouping several pieces of related information together. It is used for the storage of heterogeneous data. A union is similar to the structure, but it differs only in the way of storing the values. Let us discuss in detail about enumeration and typedef. An enumeration type is designed for the object that can have a limited set of values. Say for example, we have only 7 days in a week. So they can be created as a separate enumerated data type under an identifier name. So like how we have primitive data types, we have a range of integers under the int data type. Similarly, when we have only a limited set of values, they can be created under a new enumerated data type. Here for example, this is the syntax for enumeration definition, enum, identifier, and the set of values enclosed within the braces. So this identifier that will create the new user-defined enumerated data type. By using this identifier, we can create a variable that can have one of the values which is enclosed within this bracket. The values within this bracket is called as the enumeration constant. Say for example, enum day, within the brackets, we give the 7 days of the week. Monday, Tuesday, etc. up to Sunday. So after creating a user-defined enumerated data type, we can use that for declaring the variables. So the syntax for declaring the variables, enum, identifier, v1, comma, so list of variables, p1, comma, v2, etc. up to vn. The enumerated variables can only have one of the enumeration constant values. So whatever is given within the brackets, they can have only that those values. Like how integer data type holds integer value, these enumerated variables can have only the enumeration constants. So how to declare variables? Enum, you can give the identifier name, you give like any variable name. Here, say for example, enum day, weekday, weekend. So these variables, weekday and weekend, can take values from the enumeration constant. Say for example, you can write weekday is equal to Monday. You can assign weekend is equal to Saturday. This is how enumerated data type is created. Next is the typedef. C supports a feature known as type definition. It allows the users to define an identifier that would represent an existing data type. Here we are not creating a new data type. It represents an already existing data type, which means that typedef tries to give a new name to the already existing data type. The syntax for typedef, the keyword typedef followed by type identifier. Here the type refers to an already existing data type. Say for example, int. Identifier refers to the new name that we are going to give to the already existing data type. Typedef cannot create a new type. Instead, only a new name is given to the already existing data type. Say for example, typedef int mark. Here mark symbolizes the int data type. Now, Mark can be used to declare variables. Say for example, mark total. So instead of writing it as int total, you can write it as mark total, where mark is of type int. We already know that the expression that involves arithmetic operators are called arithmetic expressions. If the expression we have parentheses, they are evaluated first. It is considered as the sub-expression and it is evaluated first. If the parentheses are nested, the innermost sub-expression is evaluated first. We apply the operator precedence and associativity rule for that. If the operands are of different but compatible types, C automatically applies arithmetic type conversion. This is known as implicit type conversion. The lower type should be converted to a higher type. The figure here shows the conversion hierarchy. So in the lower priority or the lowest type is the short. The highest type is the long double. So next to short we have int, then unsigned int, long int, unsigned long int, float double, and finally long double. Let us discuss type conversion with one example. Int a, which means we are declaring a variable a of integer data type, which means it holds only integer value. An expression where we are going to apply the type conversion. A is equal to 2 into 3.25 plus 3 plus 6. So it is a sub-expression divided by 2, another sub-expression. So here the value 2 is of integer type. Then we have 3.25 which is of float type. Then we have 3, 6 and 2 which is of integer type. So if you see this expression, the innermost sub-expression will be evaluated first, which means 3 plus 6 will be evaluated first. So as both the operands are integer, it works in the integer mode. So the answer is 9. So you will get the expression as 2 into 3.25 plus 9 by 2. Now the next evaluation will be again the next sub-expression, which is 9 by 2. So 9 by 2, 9 is also an integer, 2 is also an integer. So the result quotient will also be in the integer value, integer mode. It will not consider the decimal data, it will take only the integer value. So which is 4. So you will get 2 into 3.25 plus 4. So next evaluation, so we will be seeing the operator precedence rule or the associativity rule. So we have two operators, multiplicative operator and addition operator. So the multiplication operator has the higher priority. So that expression will be evaluated 2 into 3.25, where you will get the answer as 6.5. So here one type is integer and another type is float. So integer is of lower type and float is the higher type. So the answer automatically gets converted to the higher type. So you will be having in decimal form 6.5 plus 4. So now a is equal to 6.5 plus 4. So initially you can see we have declared the variable a as an integer. So final result of an expression is converted to the type of the variable on the left of the assignment operator. When we are doing so, if a higher type is converted to a lower type, so in our case, so we will be having the answer as 10.5, but it is a float value, it is of the higher type, it is getting converted to the lower integer type. So if it is getting converted to a lower type, it is called demotion. The method followed during demotion is truncation, just the decimal part will be removed. So the answer will be a is equal to 10. A variable is a data name that may be used to store a data value. Unlike constants that remain unchanged during the execution of a program, a variable may take different values at different times during execution. The rules for naming the variable is same as identifiers. After deciding the variable name, it needs to be declared before it has to be used. When we are declaring a variable, it tells the compiler what the variable name is. It specifies what type of data the variable will hold. We have few variable declaration methods. See the first syntax, data type, variable name, just the variable name. and the data type. Say for example, int A. So the statement has to be terminated by a semicolon. The second syntax, if you have some list of variables, they can also be declared in a single statement like data type followed by the list of variables v1, v2, etc. up to vn. Say for example, int a, b, c. The third method, we have data type variable name equal to value. So here the value for the variable is also initialized along with the declaration. So this way we call it as initialization. So the process of giving initial values to a variable is called initialization. The value can be assigned to a variable after we declare the variable also by using the assignment operator, like say for example in the first method we have given int a. So the value for a can be assigned as a is equal to 10. In the previous three syntax, so we had the variable declaration with only the data type and the variable name. So if you see the syntax here, so we have few other facts that is included along with the variable declaration. So we have the storage class specifier, type qualifier, type modifier, then you have to give the data type, variable name, then the variable assignment. So whatever is specified within the square bracket is optional here. So we have seen in the previous three methods, we have just given only the data type and the variable name. So if we want, if there is a requirement for these factors, it can be included in the variable declaration. So in the storage class specifiers, it includes the auto, register, static, extern and typedef. It tells where the object associated with the identifier would be stored. Say for example, whether it is going to be stored in the memory or in the CPU or the registers. So next we have the type qualifiers. So they are used to indicate the special properties of the data within an object. We have const qualifier and volatile qualifier. Const qualifier, it is used for declaring an object const, announces that its value will not be changed during the execution of the program. So volatile qualifier, it says that the object has some special properties relevant to optimization. So next we have the type modifiers which we have already discussed. So they are going to give a new type to the base type. So here we have signed, unsigned, short, long. These are the few type modifiers. In this video, we discussed about data types, type conversion and variables. In the next video, we will discuss the basic structure of a C program. Hope this video was useful to you. Please don't forget to subscribe, like and share. We will meet in the next video. Thank you.